I received another power supply to evaluate today, so we're going to take this one apart and see how it works and put it through its paces. Let's get started. Received another package today. This one is an adjustable DC power supply. So let's open this one up. And check this one out. See what I received. This one's called a Matrix Technologies. In the box, it's got power cables, AC and DC power cables, and here is the unit. On the back, there's a power selector switch for your incoming power. Select either 110 or 240 volts. It's already set to 110 or 120. Comes with a standard grounded 3-prong outlet. And of course it comes with DC power jumpers with alligator clips. On the front of the unit, we've got our standard banana type plugs. Of course, it's also got binding posts so you can connect wires more permanently. So here's a display, power it on. It's got 4-digit display, and you can set your voltage. Okay, so press in to change. So if I want to change it down to 12 volts. Say I wanted to set it to 12.0. There's 12 volts. And if I want to change the current limiting, go down to amperage, and then I can set the current. So if I want to eliminate, if I want to set, it looks like a 6 amp supply, 6.1 amps. So if I want to say set my current limiting to 1 amp, that way I can set my current limiting to 1 amp. And it looks like we've got 5 different settings. So you can set 5 different memories. So if I want to say set, and I'm not reading the instructions on this, I'm just kind of playing around with it. But if I say I wanted to set memory number 1 to 3 volts, I could go in. This is most unfortunate because my microphone just died. I'm telling you guys what I'm doing, and you're not hearing me because the battery on my mic just died unexpectedly. So I went through this whole demo. We're going to set it to 3 volts. I press the voltage and current button, and then select the amperage, and I can select, say, 1 amp. And then to save it, I'm going to press and hold the memory 1 button, and that'll save it into memory 1's position. And I can do the same for memory 2, 3, 4, and 5. So for example, I want to change the voltage to 5 volts at, I forget what I set it to here, but we'll see what I get to. 3 amps, 2 amps maybe. There, 2 amps. I press and hold M2, and now I've selected 2 amps. That's how easy it is to set up. Now I did go on and set memory 3 as well. I think I set it to 12 volts at 5 amps. And then I realized my battery went dead, and I had to put the video on hold for a couple of hours while I charged up the batteries in the wireless mic. And then we continued. I set it to 13.8 volts, I believe, is what I set this one to. At I think I set it to 5 amps. Yeah, I set it to 6 amps at 13.8 volts. And then I press and hold the M3 button to save it. There's 5 memories that you can set. And for example, I've set memory 1 at 5 volts. If I look at it here, it's set to 1 amp at 3 volts. Memory 2 I've set to 5 volts at 2 amps. Memory 3 I've set to 13.8 volts at 6 amps. I'll go through how to set memory 4 and memory 5. Just because I shot it and lost it because I had no sound. So you press the voltage button. You select your voltage. Say we want to set. Say I want to set this one to 12 volts at 5 amps. So I press the voltage button, and I select my voltage. So say I want to set this to exactly 12 volts, and then I press the voltage current button, and I can cycle over here and say set this down to 12 volts at 4 amps, and I want to save that into memory location 4, and I just press and hold the memory 4 button, and it'll now save it there, right? And if I click on the V/I button, which is your voltage current test, it'll show me what is stored in there. If I want to set memory 5 to 24 volts at 5 amps, I would do the same thing. I would press the VI button, and then I would change my voltage to 24 volts, and then press the button here and go over to 5 amps, and then press and hold M5. And now I've saved the 24 volts at 5 amps to memory number 5. Now, memory number 1, I set that down to, I set that at 3 volts at 1 amp. But say I want to test an LED, and I want to limit the current flow to, say, 30 milliamps. So if I go and select the amperage setting, and I set this to 30 milliamps, right? If I want to save that, I just press and hold, and I've now saved the memory number 1 to 3 volts at 20 milliamps. So for example, if I were to short the probes together, the voltage will drop to 0, and it will tell me that I'm current limited at 30 milliamps. So if I go and get an LED, I can connect it directly across the leads, and it will receive 3 volts at 30 milliamps maximum. So here's the LED. We'll connect up the LED to my power supply, and we'll see that, and being this is a red LED, actually about 2 volts is what it's going to need to go to full brightness. But this being a red LED, this is probably going to be limited to more like 10 milliamps. So we'll set it's not a real bright one, so we'll set the current down to, say, 10 milliamps. So now I've limited the current 2 volts, 10 milliamps. If I want to save that into memory 1, I would just press and hold the M1 button. Now the voltage is set, and if I clip on the leads here, this light should light up. This LED should light up red, which it does. So 2 volts, and it's actually drawing. See, it's drawing 7 milliamps. No, it's at 10, and it's now current limited at 10, so it can't go higher. So even if I were to increase the voltage on here, I'm still going to be limited to 10 milliamps, and I'm not going to damage the LED. And 10 milliamps might even be a little too high for this one because it's just a standard LED. But as you can see, it's not going to hurt it. If I were to crank up the current, this LED is going to pop. Just like when I first hooked it up with 3 volts. As soon as I saw it starting to go dim, immediately, okay, this is a red LED. 3 volts is what you would use if you were dealing with a white LED. So if I get a white LED, let me go find a white one. Put this one back in its package. These are spares that were left over from other projects that I've been working on when I built things. I think this is from that spectrum analyzer thing that came with extra red and extra blue, so you could set it up with more red or more blue or more green. It came with different LEDs. Anyway, that's that. Let me find a white LED. That shouldn't be too much of a problem here because I've got a bunch of white LEDs here from a burned out light. So white LEDs need more voltage to light than a red LED because these are essentially a blue LED. inside the die, so nothing's going to happen. I think I'm on the right polarity here. Let's just turn the voltage up a bit. There we go. 3 volts at 10 milliamps, right? And even if I go higher on the voltage scale, it's still going to be limited to 10. See, I can give it 6 volts at 10 milliamps. It's still gonna work fine because it's current limited. But this one requires what we'll see what it requires to light. So as I dial down the voltage, the light goes down. But we get up to full brightness at around 3 volts. There we go, current limited at 10 milliamps. And this LED might actually support more than 10 milliamps of current. But we're at 2.9 volts. It's what we are set to. Set it to 3 volts. If I increase the current, it'll probably go a little brighter. But I wouldn't push it past around 30 milliamps because this is not a super bright. So this one's drawing 13 milliamps, this white LED, and this is an old Lights of America that had a bunch of these, like a cob type light, but a whole bunch of them, and some of them failed. This is one of my first LED lights that I got years and years ago, and I still use these just for pilot lights and stuff. Tear these apart. Got a bunch of old LED lights that I've taken apart like that. That are just they're junk. These old ones here were just pathetic. Anyway, that's the power supply, the basic operation. Let's try some higher power devices on this thing. So now I've got a 55 watt. I think it's 55 watts. Yeah, 55 watt car halogen headlight. It's going to draw a few more amps than an LED would draw, of course. So let's clip this on, and immediately it's going to go into overcurrent protection because a lamp like this is going to take several amps to operate. So let's just pick what did I say my current limit? I set on one of these here to 12 volts. Which one was 12? Was it M4? Yeah, 12 volts at 4 amps. Incidentally, there is a power on-off switch. You've got your main power button, of course, over here that turns the power on and off for the unit, but you've got your on and off switch over here. So if you go into overcurrent, it'll limit the current, but now we're drawing 4 amps, and you can see the voltage has dropped to 10 volts because obviously this lamp is going to take more than 4 amps. So if I turn the lamp off and I turn my current up, say I go to current and I select 6 amps, which is the maximum, 6.1, which is the maximum this power supply puts out. If I now hit the on-off button here, we're finding that the lamp at 12 volts is actually drawing 4.379 amps. That's how much current is drawn by a 50 watt or 55 watt halogen lamp at 12 volts. But if we look at one of the other settings, say 13.8, which is typically what cars operate at, we'll see that it draws, again, 4.75 pretty much. 4.74 amps is what it draws. And this will put out all day. This will drive that all day. Let's try another high current load that I've got. I've got an HID light here, HID ballast. We'll see if it'll power that up. It has a fairly steep draw to start the igniter. So let's try an HID light, which is a high current draw device. So this is an HID bulb for a car headlight. I've got another one of them here that I've actually put into this was an old halogen light that burned out. So I cut the base off it and popped an HID bulb inside here. This is just to protect the bulb so that it won't blow up. You won't get any fingerprints or anything on it. And it lets me operate on a longer term test because this will of course protect the bulb itself. And if the lamp were to explode, would contain, hopefully inside the glass, it would contain any of the fragments. So let's hook up the ballast and we'll try this one and see if it has enough current to start this little ballast, because these things here take a lot of power to get them going initially. So power supply is set for 6 amps because it's going to probably draw all of it. And there it goes. And it does have enough power to power this up, which is interesting because my other power supply, my 10 amp power supply will drive this no problem. But my other one that's sitting next to me here, it's a 5 amp supply and it won't start this. Okay, So it starts up the HID lamp, no problem. You'll see this is going to get really bright real quick. This was actually on my old car. My old car had HID lights in it. And, oh, it does still. I still have the car. I just don't drive it. My wife drives the old car now. My new car's got it's got LED lights, but I wasn't happy. I never really liked the 6000, so I bought some 4200s. This is the 4200. This is an old one, but I like the 4200s better, so I bought some new bulbs and replaced the 4300. I bought some replacement bulbs, and this is one of the original 6000s. So this thing's got like no hours on it because I took it out of the car when it was only like a month or so old and changed the bulbs to these 4300s. I just found the 4300s to be a more pleasing color to drive under. And of course, now I've got a car with it's got LED lights, which are, I think they're 5500 to 6000 Kelvin. They're quite white, but for the high beams, it uses these lights. They cheaped out. They went with halogen bulbs for the high beams and LEDs for the low beams, and the LEDs, of course, work great. But I still personally prefer this type of bulb. I like the HID lights. I really like the light from the HID lights as opposed to from the halogens and even the LED ones. This has got a really nice bright light. As you can see, it's drawing 3.1 amps. The power supply can put this out all day. The fan is not even coming on this thing. My other ones have a fan, and if I went and grabbed my other, which one is it? The Longwy or whatever I've got. No, the Longwy is the 10 amp. If I went and grabbed my other one, which is I forget what brand it is, but it's a 5 amp supply. But as soon as I put this ballast on, the fan would start running immediately. Even my Longwy, which is what normally sits up on my bench, the fan cycles on and off on it. It's a 10 amp supply though, which that's my standard bench supply, is the Longwy. This one may very well become my new power supply because it's a 32 volt 6 amp, which my other one is only a 30 volt 10 amp. So this gets an extra 2 volts, and 6 amps is generally enough for most things. So this one may very well become my new bench supply. I'm liking it already. It's powering this lamp up no problem. Let's see if I can overload this thing. If I add this extra bulb to it, I'll probably overload it. Shall we try that in parallel with it? I should be able to do it right here at the probes. Okay, so it doesn't have enough power to power this one anymore, but it does to power the incandescent bulb. Yeah, not quite enough power with the incandescent bulb running at the same time. Not quite enough initial start current to start the HID. Because these HID lamps take a lot of power when they first start. It takes a fair bit of power to get it going. But once it's running, it only draws 3.5 amps. So it draws less power because it's a 35 watt lamp. Draws less power once it's running than the other one. Fan has just started to run on. So let's take the power supply apart and see what it looks like inside. Here's a look inside. Actually looks to be quite well built. Capacitors are glued down. The transformer itself is glued down. That's good. Good heavy gauge wiring here. All the high voltage terminals for the mains have got heat shrink tubing on them. Grounded through a ground screw here. Voltage selector's got a heat shrink tubing on it. Main power switch up here has heat shrink tubing. The plugs themselves are secured, and they are paint sealed, so they're not going to come apart in shipping. And all the large capacitors are glued down. It has an MOV for a primary protection over here. Two power supplies. I've got a low voltage power supply over here, switch mode power supply. This is to power up the electronics for the main control. There's 3 circuit boards in here. The main board here. I've got another little small subboard over here, and then the control board up front with the display and the controls on it. This one's going to be the current detection and current limiting. You can see there's a big shunt coil down here, a big choke. That's going to be probably the current limiting and current measurement. On this side of the heatsink, here's our switch mode transistor. It's using Samyon caps, 1000 volt, 50 volt rating on the secondary side. The primary side are 300 volt, 330, or 200 volt, 330 microfarad caps, and that's why there's the dual voltage switch, because it's not a universal supply. If you put it on 240, and if you plugged it into 240 and your switch was set to 110, these caps are going to open up pretty quick because they're only rated at 200 volts, which is fine because you do have the switch, which would switch the configuration on it. Main power transformer here looks to be pretty beefy for what it is. It's got the main chopper transistor here. It's an IRFP250M. It's a MOSFET, an IRF MOSFET. I'm thinking that one's probably the secondary regulator for the voltage regulator for the transformer. And on the other side over here, we've got the primary MOSFET. This is the chopper, which is going to be another MOSFET, and this will be the diode, dual diode over here to rectify the AC coming off of the transformer over here, the high frequency AC. And here's our voltage control down here, and this is our MOSFET to control the voltage. Little fan in the back. This thing looks to be really well built. Looking at the soldering on this thing, I'll get a close up of it, but this thing really looks to be really well built. Yeah, the build quality on this thing looks to be really good. Just looking at it, I haven't pulled the board or anything out. I don't think I will. There's good space between the bottom of the circuit board, between the conductors and the bottom of the board. There's a good half-inch space here. Everything seems to be tight and well built. Heavy-duty components. Looks to be fairly well built. Yeah, I don't know how these caps are. Samyon, I guess it is Samjon, however they pronounce it. I don't know what the quality of those caps are, but something like this is not something that someone's going to be putting in use and using it 24 hours a day. This is a bench power supply that is going to be used on a test bench. And for anybody doing any work on like car audio or small amplifiers and stuff that needs a variable power supply, something like this is going to do the job quite well. And I think what I'm going to do with this is I'm going to take it in the house and hook it up to one of my ham radios and see how that works. I've got some smaller radios that don't take a lot of current, my mobile radios that don't take more than 6 amps, so I'm going to hook it up to one of those and do a long-term test on it, just set for 13.8 volts, see how it works with my 2 meter and 220 rigs. But hey, it's a nice looking little power supply. Matrix DC power supply. This is called an MPS3206, 32 volts, 0 to 32 volts at 0 to 6 amps. And I'm giving this one a thumbs up because I don't see anything in here that indicates that the quality is not perfect on this, at least as perfect as we can get on a modern unit. It really looks to be well built. The soldering looks to be really good on here. I don't see any bodge jobs on any of these parts. It's got some through hole as well as surface mounted. But I'm going to say that this one here looks to be a winner. I'll let you guys know if I have any problems with it when I put this into test And to say that this is the third power supply I reviewed. I reviewed this one. I reviewed the Long Wii, and I also reviewed the this one here, the Pivono. This is the 5 amp one that I reviewed. This is actually the first one that I reviewed, and I did manage to blow this one up, but I was able to fix it. I blew a MOSFET on it. I blew a MOSFET regulator, but I was able to fix it. And this one still works. I use it as a backup power supply, and now I have 2 backup power supplies. But hey, that'll pretty much do it for this video. I'm going to put this thing back together. You guys will likely see it on my bench in future videos when I need a power supply for testing, or it just may end up inside the house hooked up to one of my ham radios for a long-term test where I can test it and see how it's going to perform in the long run. But everything I've seen so far looks to be well built. Link to this one's in the description. Thanks for watching. We'll catch you in the next one real soon. Bye for now.